You're ready for, make sure I've got my microphone turned on. Yep. Okay, so you think you're ready for variables on both sides, ready for the next level. So we've mastered solving 1 and 2 step equations. We feel very comfortable with distributive property, and now it's time to add variables on both sides. So let's take a simple problem like 3x plus 2 equals 4x minus 4. Sounds good. So again, we would write what's inside here 3 times. Okay, we have a 3x plus 2, a 3x plus 2, and another 3x plus 2, and then we can just add them up, which means we have 9x plus 6. Well, Mrs. Evans, couldn't I just multiply this number times 3x and then multiply this number times 3x or times 2? Yes, you can. As a matter of fact, that's actually the ideal way of doing it, but I want you to see why that works. You're basically saying what's in the parentheses is happening 3 times. And so that leaves you with 9x plus 6 is equal to 4x minus 4. Okay? Next. Now that we have the distributing done, we're going to move into combining like terms while isolating the variable. So if I were to write this with algebra tiles, I have 9 x's. Is she going to seriously sit here and make me watch her draw all these x's? I sure am, because visualizing the model is very important. Along with 6 unit tiles. Can't draw a square to save my life, apparently. That's okay. If you want art, go see Miss Mega. And then on this side of the equal sign, the equation mat, we have 4x and we have minus 4. We have 4 reds here. Okay, so we still have our enemy lines, right? We still have to, this is still our equal sign, and we're still, no matter what side I move it to, I have to flip it. I'm thinking I'm going to go ahead and flip the 4 x's to the left side. And the reason for that is because that will leave me a lot of positive x's left over. I could take my 9x, flip them all red and move them to the right side, but then I'd have a lot of negative x's left over. And I don't want to know what negative x is equal to. I want to know what positive x is equal to. So I'm going to take my 4x, flip them red, and then move them over here. Thus eliminating all x's from here. Need a bigger eraser. This means I have no choice but to take my yellow unit tiles and move them to the right, because I've got to get the x's by themselves. So now these 6 unit tiles, which were once positive, are going to be 6 negative unit tiles added to the 4 negative unit tiles. So now what we have is 10 negative unit tiles. But before we're finished, we need to find some 0 pairs. So these guys make a 0 pair, these guys make a 0 pair, these guys make a 0 pair, and then this one and this one make a 0 pair. This means I have 5 positive x left and 10 negative units left. Okay? So 5x equals negative 10. So if I give each of these x's 2 negative tiles, that would solve our problem. Each x is worth negative 2. So let's take a look at that again. 9x plus 6 equals 4x minus 4. So then again, I chose to move these negative and move them over to the other side because I have more positives on the left than I do the right. Okay? So then I got rid of that 0 pair, that 0 pair, that 0 pair, and that 0 pair. That left me with 5x. And then that meant in order to isolate the variable, to get the x's all by themselves, I had to move them over to the units to the right and turn them negative. Okay? So now, he gets 2, he gets 2, he gets 2, he gets 2, and he gets 2. So x is equal to negative 2. How do we finish that? Looks like this algebraically. We subtract the 4x to both sides. We're left with 5x plus 6 is equal to negative 4. We move the negative 6 to the other side. 5x is equal to negative 10. Don't forget that negative sign. Then we divide both sides by 5. We've got to divide that negative 10 into 5 groups. X is equal to negative 2. Okay? Now you try.